Welcome to Deep Dive. We're the show that plunges right into the middle of, well, really compelling stories. Stuff like groundbreaking science, but also, the wilder side of human speculation. And today we are looking way, way up. Because honestly, there's nothing quite like seeing a new speck of light in the night sky to get everyone talking, right? It just ignites our imagination, makes us ask the big questions about, well, where we fit in the universe.
Yeah, absolutely.
And our subject today has done exactly that. It's an object from way beyond our solar system called 3I Atlas, and it's really captured everyone's attention. Scientists, sure, but also like the public, alien enthusiasts. It's made headlines, sparked endless online debates.
It really has. And it's more than just, an astronomical thing. It's become this sort of social phenomenon, a cosmic Rorschach test, you could say.
A Rorschach test? How so?
Well, 3I Atlas is under intense scientific study, obviously. But it's also become this magnet for some really out there speculation, conspiracy theories, the whole 9 yards. Especially, you notice, within the UFO and alien communities, particularly here in the U.S.
Ah.
Yeah, it gives us this fascinating, almost real-time view of how information and, maybe more importantly, misinformation travels in the digital age. So our mission today, let's cut through all that noise.
Right.
We're going to lay out the scientific facts, the actual dossier on this visitor.
Yeah.
Then we'll tackle that alien probe idea head on, the one that got so much traction. And finally, we'll look at how this whole story morphed online. So you, listening, get a really clear, unbiased picture.
Okay, sounds like a plan. And I think maybe the first thing we need to do is tackle some confusion around the name itself. Atlas, that seems to have muddied the waters quite a bit.
It absolutely did. And understanding this is actually key to understanding the whole public narrative that built up around 3I Atlas. So
Right.
ATLAS stands for Asteroid Terrestrial Impact Last Alert System.
Right, the asteroid warning system.
Exactly. It's this network of NASA-funded robotic telescopes. They're like tireless sentinels scanning the sky 247 for anything that might, pose a threat to Earth. And they're good. They've found thousands of objects.
Impressive.
But here's the twist. This same system discovered not one, but 2 comets, fairly close together in time, that both grabbed global headlines. Both got tagged with the ATL's name. And they could not be more different.
Okay, so 2 completely different objects sharing a name. Let's start with the first one then, the one that sort of set the stage for the confusion.
Right. That would be Comet C2019Y4 ATLAS, discovered back on December 28, 2019. And initially, the excitement was huge.
Remember that one? It was supposed to be spectacular, wasn't it?
Totally. By March 2020, it had brightened like crazy over 600 times.
Yeah.
People were saying it might become visible to the naked eye, maybe even as bright as the star Vega. It was being called the next great comet.
Oh.
And what made it even more interesting was its orbit. It looked really similar to the Great Comet of 1844. So the thinking was, maybe it's a chunk broken off, a much bigger, older comet.
Okay, so high expectations. But then,
Phil, late March, early April 2020, instead of getting brighter, it just started fading unexpectedly. And then it disintegrated. The Hubble telescope actually got pictures it broke into like 30 different pieces.
oh man, so it was a total dud.
A complete dud. Widely declared a letdown. Which brings us
To the other ATLAS comet, our main subject today, 3I Atlas.
Exactly. This one popped up on July 1st, 2025. Found by an ATLAS telescope down in Chile. And unlike its namesake, this one was flagged almost immediately as something really special. And the key word, interstellar.
Okay, so let's just really hammer this home. 2 completely separate objects. C2019Y4 from 2019, a dud from our solar system, and 3I Atlas from 2025, an interstellar visitor. Why is making that distinction so critical beyond just, avoiding mix-ups?
Because that earlier disappointment with the 2020 comet, it kind of created this narrative vacuum. People were primed for a big cosmic show, right? They got hyped up, and then it fell flat.
Yeah, I can see that.
So that lingering anticipation, that kind of collective desire for a big space story probably made people, especially maybe in those UFO and alien communities, way more receptive when 3I Atlas showed up. And it was genuinely weird. It perhaps lowered the bar for believing more sensational theories.
That makes sense, the sort of rebound effect. So, quick recap. C2019Y4 2019 discovery, Oort cloud origin, elliptical orbit disintegrated. 3I Atlas 2025 discovery, interstellar origin, hyperbolic orbit, 1 visit only. And this is the one tied to all the alien probe stuff we're going to dig into.
You got it. That's the core distinction.
All right. Now that we've cleared the ATLAS fog, let's get into the science of 3I Atlas itself. What did the telescopes actually tell us? What is this thing, scientifically speaking?
Okay, yeah, the data is pretty amazing. It really is like cosmic detective work. So first spotted July 1st, 2025. Just this incredibly faint dot, 18th magnitude. You need serious telescopes to see
Where
that.
it's barely visible.
Right. But within 48 hours, follow-up observations confirmed it had a coma, that fuzzy cloud of gas and dust around it, and maybe even a faint tail. Yeah. That sealed the deal. It was cometary, so it got its official designations. 3I Atlas, the third confirmed interstellar object, and also C2025N1 ATLS, its standard comet name.
The third one after Umala and Borisov.
Exactly. But what really makes 3I Atlas stand out is its trajectory. Its orbital eccentricity, basically how stretched out its orbit is compared to a circle, is about 6.2.
6.2. And remind us, what were the others?
Umla was around 1.2, Borisov was 3.4. Anything over 1 means it's hyperbolic, it's not bound to our sun, it's just passing through. And 6.2 is, well, it's extreme. Its path through our solar system looks almost like a straight line.
Wow, just slicing through.
And the speed, unbelievable. It came into our system doing over 130,000 miles per hour, roughly twice as fast as the other two interstellar visitors. Just way too fast for the sun's gravity to ever hope to capture it.
So no chance of it sticking around. Where did it come from and where's it going?
It arrived from the direction of the constellation Sagittarius, its closest point to the sun perihelion, that's set for October 29-30th, 2025. It'll be about 1.4 AU out, and AU is the Earth-Sun distance, so just inside Mars's orbit.
And closest approach to Earth. Any danger?
Nope, not at all. Closest pass to us is December 19th, 2025, at a very safe 1.8 AU. That's about 170 million miles away. Poses zero threat.
Okay, good to know. So a confirmed interstellar speed demon on a one-way trip. Fascinating trajectory. But what about the object itself? What's it made of?
Now that is where things get really interesting, because its chemistry is seriously weird. Initially, because it looks so bright far out, estimates put its nucleus, the solid core, at maybe 20 kilometers across. Pretty big.
Yeah, that's substantial.
But then better observations, especially from Hubble, forced a major rethink. The nucleus is probably tiny. The upper limit is now maybe 5.6 kilometers, but most likely it's less than 1 kilometer across.
Less than a kilometer, so why did it look so big and bright at first?
Because of its coma. It wasn't a big rock, it was throwing off a huge reflective cloud of gas and dust. And the composition of that gas, that's the kicker. James Webb Space Telescope, SEPHIC-REx, this new infrared spacescope, they found that coma is incredibly rich in carbon dioxide, CO, and relatively little water, HO, and carbon monoxide, CO.
Rich. How rich?
We're talking like an 8-to-1 ratio of CO to water ice being released. That is one of the most extreme ratios ever seen in any comet, from our system or otherwise.
Whoa. 8 times more curious than water? What does that tell us? That seems really significant. Does that mean it formed somewhere like super cold in its home system?
Oh.
Colder than where our comets form?
Exactly right. Co-Euro's ice turns into gas subliments at much lower temperatures than water ice. So having loads of it explains why 3I Atlas was so active, so bright. Even when it was really far from the sun, it was shedding gas and dust like crazy, making it look much bigger than it is.
Okay, that makes sense now. The 2 Euro drove the early brightness, not the size. What else did they find?
Well, the Very Large Telescope, the VLT, also detected cyanide gas CN, which is pretty common in comets. But it also found atomic nickel vapor, which is unusual on its own, but the really weird part, no corresponding iron vapor.
Nickel without iron, why is that weird? Don't they usually go together?
They almost always do in cosmic environments we've studied. Finding nickel vapor without iron strongly suggests some kind of unique chemical process or environment in its parent star system, something we haven't observed directly before. Visually, by the way, it has this distinct reddish color.
Reddish.
Like some asteroids we call D-types, and actually like the other interstellar comet, 2I Borisov. That color probably comes from complex organic gunk, called tholins, basically. Space tar formed by billions of years of radiation exposure. And yes, it definitely has a visible coma and a faint dust tail pointing away from the sun.
Okay, so co-Euros, nickel without iron, reddish, tiny nucleus, huge coma. Where did this oddball come from and how old is it?
Well, the trajectory traces back towards Sagittarius, like we said. And that co-Euro dominance plus the nickel thing really points to it forming in an incredibly cold part of its parent star's protoplanetary disk, way out beyond the co-Euro frost line, much further out than where our own Oort cloud comets likely formed. Then it got kicked out into interstellar space somehow. As for age, based on its high speed, older star populations tend to have higher velocities. The estimates range from maybe 7.6 billion years up to possibly 14 billion years old.
14 billion. That's potentially older than our own sun, older than our solar system.
There's a real possibility. It could be an ancient relic from the early galaxy.
Okay, here's where it gets really interesting for me. Beyond just being a weird space rock, what's the big picture significance here? What does finding something like this mean?
It means we're doing interstellar archaeology.
Yeah.
Seriously. Think of Three-Eyed Atlas not just as a comet, but as a physical piece, like a core sample drilled from an alien world's construction site billions of years ago.
Wow, okay. A core sample.
Yeah, we're not just analyzing light from distant stars anymore. We have actual material from another star system right here that we can study. Instruments like Webb can basically do a chemical analysis, give us a direct chemical fingerprint of the conditions in another part of the galaxy long ago.
So it's like ground truth for planet formation models.
Precisely. It's unprecedented data to test and refine our ideas about how planetary systems form and evolve everywhere. It's a direct peek into the sheer chemical diversity out there.
Okay, so the science paints this picture of a truly fascinating, ancient, chemically weird interstellar comet. An incredible scientific opportunity. But that's not the only story being told, is it? Not everyone sees Three-Eyed Atlas as just a natural object. And this is where Professor Avi Loeb enters the picture in a big way.
Indeed. And you have to understand who Avi Loeb is. He's a Harvard astrophysicist,
Yeah.
very senior, highly published, very respected in many areas of theoretical astrophysics.
Right, not exactly some random person online.
Not at all. But in recent years, he's become, let's say, quite famous for making controversial claims, most notably arguing that the first interstellar object, Oumuamua, might have been an alien artifact, maybe a light sail.
I remember that causing a huge stir.
It did, and it sort of established this pattern for him, seeing anomalies in astronomical data and proposing extraterrestrial technology techno-signatures as a possible explanation. So when Three-Eyed Atlas came along with its own set of weird characteristics, he applied that same lens. And that perspective really resonated with certain groups, especially, again, the UFO and alien communities in the U.S.
So how did he build the case for Three-Eyed Atlas being artificial? Was there some smoking gun evidence?
Not exactly a smoking gun. His argument, laid out with collaborators mainly in a preprint papers, and not peer-reviewed initially, was based on what they called a chain of improbabilities. The idea is that while any single weird thing might be natural, the combination of weird things about Three-Eyed Atlas is so statistically unlikely that maybe, just maybe, an artificial origin is the more plausible explanation.
Okay, a chain of improbabilities. What were the links in that chain, according to Loeb?
Well, first was the trajectory coincidence. Its orbit, while interstellar, happens to be aligned within about 5 degrees the ecliptic plane that's the plane our planets orbit in. He calculated the odds of a random object doing that as only 0.2%. So maybe not random, maybe deliberate targeting.
Okay. 0.2% does sound low. What else?
Then there's the planetary flyby coincidence. He argued its path takes it conveniently close to Mars, Venus, and Jupiter. The odds of that happening randomly, he put it at an even tinier 0.005%. So again, maybe it's not random. Maybe it's like a mapping mission or reconnaissance, deliberately swinging by these planets.
I can definitely see how stringing those kinds of probability arguments together could sound suggestive, especially if you're already looking for something non-natural.
Exactly. Then they pointed to the early size-brightness paradox. Remember how it looked really bright at first, suggesting a huge nucleus? But early spectroscopy didn't show obvious gas. Loeb framed this as a contradiction. How could it be so bright without spewing gas? Unless it wasn't a comet. Of course, later data resolved this, but it was part of the initial argument.
Okay, what else was in this chain?
The perihelion concealment. Its closest approach to the sun, when it should be brightest and most active, happens when it's on the far side of the sun from Earth's solar conjunction. Loeb presented this as potentially a tactical maneuver. Maybe the aliens are hiding propellant burns or deploying smaller probes while they're hidden from our view.
A tactical maneuver, wow.
Yeah. And finally, there was this thing called the antisolar glow. Early Hubble images showed a slight elongation pointing towards the sun. Loeb called this highly unusual because comet tails point away from the sun, so another anomaly in the chain.
So, trajectory, flybys, brightness, hiding behind the sun, weird glow. Taken together, Loeb argues this points away from nature.
That's the core of his argument. It's presented as a choice between accepting a string of natural coincidences, each very improbable, or considering an artificial origin.
And if it is artificial, what does Loeb think it might be doing here? What are the implications in his view?
Well, his framework often brings up the dark forest hypothesis. The idea from science fiction that advanced civilizations stay quiet because advertising your existence might attract hostile predators.
Right, stay hidden or risk destruction.
So in that context, 3i Atlas could be seen as a stealthy reconnaissance probe, maybe checking us out. And Loeb didn't mince words in his paper. He and his co-authors explicitly raised the possibility that its intentions could be malign and might even require defensive measures from humanity.
Whoa, okay. That's a pretty dramatic claim. Malign intentions, defensive measures.
It definitely is. And that kind of language really fueled speculation online, especially in those UFO and alien communities. You saw other theories pop up too, building on Loeb's ideas. Maybe it's nuclear powered, maybe it's a decoy, maybe it's some kind of hybrid asteroid spacecraft designed to look natural. The argument became, which is less likely, a series of natural flukes or one alien probe. Loeb leaned towards questioning the natural explanation.
Okay, so we have Loeb's hypothesis built on this chain of perceived improbabilities, gaining traction, especially in certain online spaces. But
Huh.
what does the broader scientific community say? Surely they didn't just accept this. There's all that other data we talked about.
Oh, absolutely not. The mainstream scientific consensus is very clear, and it's backed by that wealth of observational data, especially from Webb and VLT. NASA's lead scientist for this stuff, Tom Statler, put it very bluntly. 3i Atlas looks like a comet. It does comet things. Full stop.
Right. Simple as that.
For the vast majority of astronomers, it's an incredibly exciting natural object, offering a priceless scientific opportunity, not an alien probe. And they have strong, evidence-based explanations for every single one of Loeb's anomalies.
Okay, let's break those down then. How does the mainstream science explain away that chain of improbabilities, starting with the trajectory and flybys being so unlikely?
Well, unlikely doesn't mean impossible, especially in astrophysics. Yes, the odds for any one random object hitting that specific trajectory might be low. But our galaxy has billions of stars, ejecting trillions, maybe quadrillions, of objects over billions of years. Statistically, some objects are bound to have trajectories that look coincidental from our perspective. Plus, there's observational bias. We're more likely to detect objects that happen to pass through the inner, well-observed part of our solar system. So it's interesting, but perfectly explainable by chance and celestial mechanics.
Okay, so low probability doesn't automatically equal artificial. What about the size-brightness paradox and the composition?
Completely resolved. The JWST and Spherix data nailed it. It's not a paradox at all. It's a small nucleus, less than a kilometer probably, but it's loaded with co-Euros ice. That co-Euros sublimates like crazy even far from the sun, creating a huge bright coma. That explains the early brightness. The initial lack of detected gas was just a limitation of the first instruments used. Webb clearly saw the gas later. No contradiction.
Makes sense. And the perihelion concealment hiding behind the sun?
That's just basic orbital mechanics. It's called solar conjunction. It happens all the time when Earth, the sun, and another object line up in that order. It's entirely predictable based on their orbits, not some sneaky maneuver.
Right, a standard celestial alignment. And the anti-solar glow, that weird elongation towards the sun.
Also a well-understood comet feature. It's called a dust fan or a plume. Comets rotate, and jets of gas and dust shoot out from active spots on the nucleus, often on the sun-facing side. From certain viewing angles, this creates a fan-like feature that appears to point generally sunward, even while the much fainter, larger dust tail is pushed away by solar radiation pressure, exactly as expected. Hubble saw exactly this kind of feature.
So also normal comet behavior. What about the nickel without the iron? That still sounds weird.
It is weird, but weird in a scientifically exciting way, not an artificial way. It tells us something new about chemistry in other star systems. It points to a unique natural formation environment, maybe specific temperature or pressure conditions we haven't encountered before, that allowed nickel to vaporize or be incorporated differently than iron. It's a clue about natural processes, not alien tech.
This feels very different from the debate around Oumuamua. With that one, the alien idea seemed to hang around longer, even among some scientists. Why was 3i Atlas seemingly debunked as artificial much faster and more decisively?
That's a really key point. With Oumuamua, the data was just sparser. We saw it late, its shape was only inferred, and crucially, it showed non-gravitational acceleration speeding up slightly without a visible coma or tail to explain it. That ambiguity, that lack of clear outgassing, created the opening for the light sail hypothesis.
Right, there was a genuine puzzle there.
Exactly. But with 3i Atlas, we spotted it earlier, and we hit it with our best instruments, Webb, Hubble, VLT, almost immediately. We got unambiguous compositional data showing its co-Euro, which perfectly explains why it would be active and could show non-gravitational acceleration even far out. We got clear images of the coma and tail. The science effectively closed the ambiguity gap very quickly, providing natural explanations for all the weirdness.
So the evidence just overwhelmingly pointed towards Comet. How did the scientific community react specifically to Loeb pushing the artificial narrative despite this data?
There was significant pushback. Many prominent astronomers publicly called Loeb's claims things like nonsense or even insulting to the scientific process. They pointed out his paper wasn't peer-reviewed, and that framing it as a pedagogical exercise, as he did, seemed like a way to float speculative ideas without rigorous backing.
Yeah, that sounds like hedging.
Some critics also questioned his motivations, suggesting it might be more about generating publicity, maybe selling books, than pure science. There was real concern that this kind of high-profile speculation, coming from a Harvard professor, could actually harm legitimate SETI research, the search for extraterrestrial intelligence, by blurring the lines between careful science and sensationalism in the public eye.
Okay, so the scientific consensus is solidly natural, albeit weird, comet. But that's clearly not the whole story because the alien probe idea definitely took off online. How did that happen? How did this scientific debate play out in the digital world, especially within those UFO and alien communities you mentioned?
Oh, it's a textbook example of how narratives just splinter online these days. Take Reddit, for instance. It was like looking at two different realities depending on which subreddit you visited.
How so?
In places like Space or astrophysics, the discussion was mostly skeptical of Loeb. People shared the scientific papers, the rebuttals from other astronomers, the images from Webb showing the coma. There was critical analysis of Loeb's arguments and sometimes his motives.
Okay, the science-focused groups stuck to the data.
Pretty much. But then you hop over to RUFOs, Raelians, High Strangeness, huge communities, very active in the U.S., and the reception to Loeb's ideas was way warmer. There, his anomalies were often treated as strong evidence for artificiality. Mainstream scientific explanations were frequently dismissed as, institutional bias, closed-mindedness, or even part of a deliberate cover-up.
The classic lone genius fighting the establishment narrative.
Exactly. That narrative is incredibly powerful in those communities. And then you go to places like Conspiracy, and it gets woven into even bigger tapestries. Like one theory that gained traction, which Loeb himself acknowledged hearing, was that the whole 3ILS media buzz was manufactured a deliberate distraction campaign by the powers that be to pull attention away from other things, like, say, the latest Jeffrey Epstein document releases happening around the same time.
Wow. So connecting cosmic mysteries to terrestrial politics, what about other platforms like Twitter or 4chan?
Yeah, similar patterns. On fringe platforms like 4chan, a lot of the discussion seemed filtered through YouTube videos explaining Loeb's theory, often mixing it with existing U.S. political conspiracies. On X, formerly Twitter, the nature of the platform short posts, rapid spread favored sensationalism. You saw these viral threads just listing Loeb's anomalies without much scientific context. One connection that went absolutely wild on X was linking 3ILS's origin point in Sagittarius to the famous WOW signal detected from that same direction back in 1977.
Connecting it to a pre-existing alien mystery. That makes sense for engagement.
Totally. It slots the new anomaly into an established mythology.
So it sounds like traditional media, YouTube, maybe even other shows like this one, played a big role in shaping how people understood or misunderstood 3I-Atlas.
The huge role. It created this feedback loop. Mainstream news outlets, knowing the alien probe angle gets clicks, often led with that, even if the article eventually mentioned the scientific consensus further down. That coverage then fueled more public interest and discussion online, which in turn justified more sensational media coverage.
The clicks drive the narrative.
Pretty much. And on YouTube or other podcast platforms, you have this complete split. Some channels were dedicated to carefully debunking the speculation, explaining the science. Others became echo chambers, amplifying the most extreme versions of the alien probe theory, sometimes featuring Loeb himself. So basically, your understanding of 3I-Atlas likely ended up depending heavily on which information bubble, which algorithmic feed you already lived in.
That's quite a picture. This whole saga, this, as you called it, splintering of how people interpreted the same event. What does it really tell us about our information environment today? How we process these big, complex scientific discoveries as a society?
I think it really highlights this splintering of consensus that's become so characteristic of the digital age. Scientific information used to flow more top-down, right? from journals, institutions, trusted science communicators, now gets instantly filtered, interpreted, and often distorted through these online communities, curated by algorithms designed for engagement, not accuracy.
So the same data point gets totally different meanings depending on the tribe.
Exactly. The JWST data showing high sea Euro levels becomes definitive proof it's a natural comet in astrophysics. But simultaneously, it's twisted into evidence of sophisticated alien tech that doesn't need water, proving it's artificial over in aliens. The objective reality of the object itself almost becomes secondary to what that object represents within the worldview and identity of the group discussing it.
That's kind of scary, actually.
It has profound implications for how we as a society deal with complex science, not just in astronomy, but across the board. It makes establishing a shared understanding, a common ground based on evidence, incredibly difficult, especially for topics that touch on deeply held beliefs or fears, like the possibility of alien contact.
Wow, what a journey we've been on with this thing. From a faint dot in the sky to interstellar archaeology to online conspiracy theories, this deep dive into 3i Atlas really packed a punch, didn't it? It's so much more than just a space rock story.
It really is. If we synthesize it all,
Yeah.
the scientific verdict is crystal clear. C2019Y4 was just a regular solar system comet that fell apart. 3i Atlas, on the other hand, is a bona fide interstellar visitor, natural, fascinatingly weird, and scientifically invaluable. Its unusual chemistry is giving us real clues about how diverse planetary systems might be out there.
But the story doesn't end there.
No. The whole episode also underscores the strange power of the credible outsider in our current media landscape. Professor Loeb, with his Harvard credentials, gave this speculative alien narrative a sheen of legitimacy that made it much harder for the public to dismiss than, say, your average internet conspiracy theory.
It lent weight to the fringe ideas.
Precisely. And it also shows us how science itself operates now, increasingly under intense, real-time public scrutiny. Data gets released fast, preprints circulate instantly, social media explodes. It speeds up discovery, yes, but it also creates this chaotic environment where misinformation can spread just as quickly, if not faster, than verified facts. Public understanding struggles to keep up.
You know, all the intense public fascination, the arguments, the speculation, it does seem to tap into something really fundamental about us, doesn't it?
I think so. It reflects this deep, almost primal human hunger for connection, for meaning, for knowing if we're alone in the cosmos. It's interesting, Professor Loeb himself has mused about this. He suggested that maybe the way humanity reacted, the tribalism, the splintering of consensus, the arguments might itself be an answer to Enrico Fermi's old paradox. Where is everybody?
How so?
Well, maybe any truly advanced intelligence watching how we handle something like 3i Atlas, how we interpret data, how we argue amongst ourselves, maybe they just conclude that humanity is not yet ready for contact, that our own divisions are the reason the universe seems quiet.
Huh. That's a provocative thought. Our reaction to the messenger becomes the message itself. What a fascinating deep dive this has been. Truly a story of cutting-edge science, wild speculation, and ultimately human nature, all bundled up in one visitor from the stars.
Couldn't agree more. And maybe the real message carried by 3i Atlas isn't ultimately about the star system it came from, but about us. A reflection staring back at us, showing our capacity for incredible wonder, but also for fear, and the immense challenge we face in finding shared understanding in this overwhelming age of information. It really makes you think, doesn't it? If we were sending a message out to another civilization, what would it be? And, perhaps more importantly, how would they interpret it through their own filters?
A profound question indeed, something for all of us to ponder. Well, that's all the time we have for this dome dive. Until next time, keep looking up, keep asking questions, observe the world and the cosmos with a curious, critical eye, and keep doing your own deep dives into whatever sparks your curiosity.